Welcome folks to our video today on significant figures, sometimes called significant digits. And the question has sometimes come up in mathematics, I'm sure. How many digits do I put into this answer? Should I put 4? Should I put 5? Well, the good news is significant figures, they have rules which we can follow to help us to understand that. So this person here who says he's 5.00000 years old, the good news is we have a solution for this man in terms of how many digits he should be using. Clearly it's 5, right? So the first thing to say is significant figures are significant. They are important. They tell us something about the precision of our measurements or lack of precision. So we're talking about science here and we're guided by the tools that we use for measurements. So if we wanted to measure these green bars, we can look at 3 different scenarios here. The first scenario, we've got a ruler which doesn't have a lot of granulation here. It doesn't have these pieces in here to tell us. We just know it's between 0 and 1. So we're going to take a best guess at 0.3 because the significant figures in any measurement are those whose digits are known with certainty plus 1 additional digit that we have to guess. So in this case we had to guess this digit here, that it's 0.3, and so there's 1 significant digit. In the second scenario here, luckily we have a little bit more to go on here. We know that it's in between 0.2 and 0.3. And so we're going to guess that it is about 0.26. And so that's using 2 significant digits. In the third scenario here, we have yet more information here. And we can see that it is somewhere between 0.27 and 0.28. So we might say 0.275. So that gives us a little bit of a guideline as to how many significant digits to use. Now there's also rules for counting significant digits. There are a lot of rules which you can follow up here. For example, zeros before numbers are not significant, between numbers are always significant, and so on. I'm just going to give you a little bit of a shortcut here for trying to think about and recognize how many significant digits we're looking at. And so we're going to start with the beautiful country of Canada. I've put a little maple leaf here. And we're going to recognize that the Pacific Ocean is on the left, Atlantic is on the right. Now in my little crutch method here, if a decimal place is present in the number, we're going to start on the left in the Pacific Ocean side. And we're going to keep going until we hit a non-zero and count all the numbers after this. So in the first one, decimal place is present, but we're going to hit that number 5 straight away over here, and we're going to count everything after that. So we have 1, 2, 3, 4, 5. Okay, so we actually have 5 significant digits there. We're going to have a look at this again here. We have we start on the left. And we're going to keep going until we hit a number, which in this case was 7, and then we count thereafter. So we have 1, 2, 3, 4, 5. So again we have 5. Notice that this middle 0 is significant. Also this end 0 was significant too. And so there was more precision in that measurement device. It wasn't 705.8, it was 705.80. That's important. Now let's look at this scenario here. Again, the decimal place is present, so we start from the left, but this time we can ignore these zeros, and we're going to count once we hit a non-zero number. So we have 1, 2, 3. So in fact, in this bottom one, 0.00510, we don't have 6 or 5 significant digits. We only have 3. So these zeros here, we sometimes, the trailing zeros on the left, we sometimes call them placeholders. Now what if a decimal place is absent? Well, then we're going to start on the Atlantic Ocean side, and we're going to go until we hit a non-zero number, and then count thereafter. So in this case we have 1, 2, 3, 4. So we have 4 significant digits in the first one. And what about the population of Canada, which is approximately 38 million? So in this case, we can Ignore these trailing zeros. The decimal place is absent. That is to say, there's no decimal place there like that. So we're going to count once we hit a number, and it's 1, 2. So in actual fact, this bottom number only has 2 decimal places. So that's a rule for counting decimal places. What about multiplying and dividing? Multiplying and dividing significant figures. Well, the answer has the same number of digits as the least significant figure. So if we look at this one here, this is why it's important to be able to count how many and recognize how many there is. We know from our rules that there's 3. It's a little bit easier when there's no zeros. It's just the number, the full number. And in this case, there's 2. So the least number of significant digits is 2. It's the least precise. So we cannot be more precise than the least precise. It's kind of like the weakest link in the chain, if you like. So when we multiply these two numbers in here, we're going to get a value which is 9.63. So this would be 9.63. The problem here, though, is that we can only have an answer to 2 significant digits, which we talked about. So we must use 2 significant digits, and then the question is, the digit out here tells us whether we round up or down. So this becomes 9.6. So when we're multiplying or dividing, we look at the least significant digit, the least significant figure, and we use that as a guideline. Whether you're multiplying or dividing, same thing. Slightly different if we're adding and subtracting. The number has the same number of decimal places as the figure with the least number of decimal places. So let's look at one here, 20.157, and we're going to add 3.2. And so when we do that, we look at the one with the least number of decimal places. This has 3. This has 1, so our answer must have 1. Now we can put our answer in firstly and say 23.357, but we really should be rounding this so that it just has 1 decimal place. So these are going to cause us, these 2 digits here are going to cause us to round up, and so what we end up with here is 23.4, and that gives us a nice figure which has got 1 decimal place following our rules. Now what about scientific digits, significant digits in scientific notation, I hear you say? Well, the good news is it's pretty easy. For that, if we want to know how many significant digits there is when looking at a scientific notation figure, we just look at this number on the left, which has the name of a mantissa. It's called a mantissa. And that will guide you as to how many significant digits there is. It's always shown in a scientific notation value. And the second part is, if you are trying to establish how many significant digits to use when multiplying or dividing or adding and subtracting, you follow the same rules. So for multiplying and dividing, we would look at the least number of significant digits. So in our example here, 4.6 by 10 to the 9 divided by 2.25 by 10 to the 6. We're going to handle the mantissas separately and then the exponents and see how we go. So there's 2 significant digits here, there's 3 here, so our answer must be in 2, which is the least significant. So you can get a calculator to do this as well, but we can take them separately, and we're simply going to, actually that says multiply, it should be divide, oops. We're simply going to divide here, and we're going to get this number here, and then we're going to make sure that that is to 2 significant digits. And so 2 significant digits is 2.0, and then we're going to go over to the exponent side. We're going to divide the exponents, and of course you take those away as you would have learned previously, and so that's 10 to the 3. And so what we get here is we get 2.0 by 10 to the 3, and our answer is in 2 significant digits.